In this video, I will teach you how to balance chemical equations. All of the following represent chemical reactions. Your job is to write the correct balanced equation using the lowest possible whole number coefficients. And you do not have to include phases of matter such as solid, liquid, or gas. In our first reaction, iron, which has the symbol Fe, reacts with chlorine, which has the symbol Cl. But remember, there are 7 diatomic elements that were mentioned in your properties of matter packet. These include hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So we represent chlorine as a diatomic element, and it produces iron 3 chloride, which has the formula FeCl3. Now we have an equation. Let's stick in the proper coefficients. The least common multiple of 2 and 3 is 6. And when we use a coefficient in front of a chemical formula, the coefficient multiplies each subscript in the formula by the value of the coefficient. So to get 6 chlorine atoms on the left, we add a coefficient of 3. And to get 6 chlorine atoms on the right, we add a coefficient of 2. But now that we have 2 iron atoms on the right, we have to get 2 iron atoms on the left. Now the equation is balanced. Now for our next reaction. Remember, you can pause the video if you haven't balanced these equations yet and try it on your own before you see the answer. We start with phosphorus, which this particular form has the formula P4. It reacts with oxygen, which remember is one of the 7 diatomic elements, so we write O2, and it produces diphosphorus pentoxide, which has the formula P2O5. So we're going to use coefficients based on the fact that the least common multiple of 2 and 5 is 10. So we have 10 oxygens on the left, and now we have 10 oxygens on the right. This also gives us 4 atoms of phosphorus, so the equation is balanced. In our next reaction, aluminium reacts with oxygen to produce aluminium oxide. So the formula, the symbol of aluminium is Al. It reacts with oxygen, which is written as O2, and it produces aluminium oxide, Al2O3. There are 2 aluminium atoms on the right, so we need 2 aluminium atoms on the left. The least common multiple of 2 and 3 is 6, so we balance the oxygens with a coefficient of 3 and 2. But now there are 4 aluminium atoms on the right, so we need to change the coefficient for aluminium from a 2 to a 4. Now the equation is balanced. In our next equation, we start with sodium nitrate, and this produces sodium nitrite and oxygen. So the formula of sodium nitrate is NaNO3, and the products of the reaction are sodium nitrite, NaNO2, and oxygen, which is written as O2. There are 3 oxygen atoms on the left, but there is a total of 4 oxygen atoms on the right. So one method of balancing this equation is to use a fraction in front of the O2 that will balance the oxygen atoms. So now with a 1/2 in front of the O2, there is a total of 3 oxygen atoms on both sides. The equation is balanced, but our coefficients need to be the lowest possible whole numbers. So all we have to do now is multiply each coefficient by 2. So in the final answer for this particular equation, the coefficients are 2, 2, and 1, which is understood. We don't have to write a 1 as the coefficient. Now, another method of balancing this equation would have been to increase the number of oxygen atoms on the left. So suppose that we put a 2 in front of the sodium nitrate. This would increase the number of oxygen atoms on the left. Now we have 2 sodium atoms, 2 nitrogen atoms, and 6 oxygen atoms on the left. If we balance the sodium atoms, then everything else will become balanced as well. We have 2 nitrogen atoms on both sides and a total of 6 oxygen atoms on both sides. So we get the same answer as we did earlier. All right, our next equation starts with aluminium chloride, AlCl3, and the products of the reaction are aluminium and chlorine, which is a diatomic element, so it's written as Cl2. The least common multiple of 2 and 3 is 6, so we want to get 6 chlorine atoms on the left and 6 chlorine atoms on the right. Finally, we need to balance the aluminium atoms, so a 2 in front of the aluminium takes care of the balancing process. All right, our next chemical reaction involves ammonium nitrate, which has the formula NH4NO3, and there are 3 products of this reaction. We have nitrogen, which is one of the diatomic elements, oxygen, also diatomic, and water, H2O. The formula of ammonium nitrate contains 2 nitrogen atoms, 4 hydrogen atoms, and 3 oxygen atoms. Now the nitrogen atoms are already balanced on both sides, 2 and 2. The oxygen atoms are already balanced on both sides. We have 3 on the left and 3 total on the right. However, we need to balance the hydrogen atoms. So when we do this, by putting a 2 in front of the H2O, it will affect the number of oxygen atoms. So now we have 3 oxygen atoms on the left, but we have 4 total oxygen atoms on the right. So what do we do here? Well, one method of balancing this equation is to use a fraction in front of the O2 to balance the oxygen atoms. So at this point, the equation is balanced, but our coefficients need to be the lowest possible whole numbers. Like we saw before, all we have to do is multiply each coefficient by 2. So the final answer would have coefficients of 2, 2, 1, and 4. So at this point, the equation is balanced. And if you're not interested in using fractions to balance a chemical equation, let's go back to the point at which we had 3 oxygen atoms on the left and 4 oxygen atoms on the right. So another method of balancing this equation would be to increase the number of oxygen atoms on the left. Let's add a 2 on the left and see what happens. Well, that 2 changes everything on the left side. So now we have 4 nitrogen atoms, 8 hydrogen atoms, and 6 oxygen atoms on the left. If we balance the nitrogen atoms with a 2, and if we balance the hydrogen atoms by changing the coefficient to a 4, this will actually balance the oxygen atoms as well. So we have a grand total of 6 oxygen atoms on the left and on the right. So we get the same answer as we did earlier. All right, let's take a look at our next chemical reaction. We start with aluminium. It reacts with sulfuric acid, which has the formula H2SO4. And the products of the reaction are aluminium sulfate, which has a formula Al2, and then SO4 in parentheses times 3, and hydrogen, which is one of the diatomic elements. Now we have not seen in all of the reactions so far any examples of formulas with parentheses. Let's talk about that. If we balance the aluminum atoms, we can put a 2 on the left. The SO4 atom group, which is inside the parentheses on the right, is multiplied by 3. So there are 3 sulfur atoms and 12 oxygen atoms on the right. To balance these atoms, we can place a 3 in front of the H2SO4. Now the last element we need to balance is the hydrogen. So if we have 6 hydrogens on the left, we can balance the hydrogen atoms by putting a 3 in front of the H2. And now the equation is balanced. Okay, on to our next chemical reaction. This one starts with potassium, which has the symbol K. It reacts with water, H2O, and the products of the reaction are potassium hydroxide, KOH, and hydrogen, which is one of the diatomic elements. All of the elements are balanced except for the hydrogen atoms. There are 2 hydrogen atoms on the left, but there is a total of 3 hydrogen atoms on the right. So one method of balancing this equation is to use a fraction in front of the H2 to balance the hydrogen atoms. So now there are 2 hydrogen atoms on both sides. The equation is balanced, but our coefficients need to be the lowest possible whole numbers. So when we multiply each coefficient by 2, our final answer has coefficients of 2, 2, 2, and 1. And the equation is now balanced. Let's go back to the point at which we had 2 hydrogen atoms on the left and 3 hydrogen atoms on the right. If you did not choose to use a fraction to balance this equation, another method would be to increase the number of hydrogen atoms on the left. So let's add a 2 in front of the water and see what happens. Now we can balance the oxygen atoms by putting a 2 in front of the potassium hydroxide. And we can balance the potassium atoms by putting a 2 in front of the potassium. Now at this point, we have a total of 4 hydrogen atoms on both sides. So we get the same answer as we did earlier. In our next reaction, we start with a chemical called limonene, which has the formula C10H16. So that's carbon and hydrogen. It reacts with chlorine, which is a diatomic element. It produces carbon, which has the symbol C, and hydrogen chloride, HCl. We can start by balancing the carbon atoms. So we're going to put a 10 in front of the carbon. Then we can balance the hydrogen atoms. So we can put a 16 in front of the hydrogen chloride. And then finally, to get 16 chlorine atoms on the left, we can put an 8 in front of the Cl2. And now the equation is balanced. Our next reaction involves a chemical called iron 3 bromide, FeBr3. It reacts with lithium sulfate, which has the formula Li2SO4. The products of the reaction are iron 3 sulfate, so Fe2 and then parentheses around the SO4 times 3, and finally lithium bromide, which is LiBr. We can start by balancing the iron atoms, so let's get 2 iron atoms on the left. Now this will give us 6 bromine atoms on the left. So we can take care of that by putting a 6 in front of the lithium bromide. Now, if we have 6 lithium atoms on the right, we can put a 3 in front of the lithium sulfate. Now that 3 multiplies the SO4 atom group by 3, which is exactly what we needed to balance the entire equation. So the equation is balanced with coefficients of 2, 3, 1, and 6. Our next equation starts with silver nitrate, which has the formula AgNO3. It reacts with aluminium chloride, AlCl3, and the products are aluminium nitrate, Al, NO3 in parentheses, times 3, and finally silver chloride, AgCl. The NO3, which is called nitrate, that group of atoms is multiplied by 3 on the right, so we have 3 nitrogen atoms and 9 oxygen atoms on the right. To balance these atoms, we have to place a 3 in front of the silver nitrate. This gives us 3 atoms of silver on the left, so we can put a 3 in front of the silver chloride. This also gives us 3 chlorine atoms, which is what we wanted anyway, so now everything is balanced, and the coefficients from left to right are 3, 1, 1, and 3. In our next reaction, we start with a chemical called lead-2 nitrate. It reacts with potassium iodide, and it produces lead-2 iodide and potassium nitrate. So we see the NO3, which is called nitrate. That atom group is multiplied by 2 on the left, giving us 2 nitrogen atoms and 6 oxygen atoms on the left. Let's place a 2 in front of the potassium nitrate, which will balance those atoms. Now we have 2 potassium atoms on the right, so let's put a 2 in front of the potassium iodide. This will give us 2 atoms of iodine on the left, which is what we wanted anyway. So now everything is balanced, and the coefficients from left to right are 1, 2, 1, and 2. Our next reaction involves calcium hydroxide. So we see an OH in parentheses multiplied by 2. That chemical reacts with phosphoric acid, H3PO4, and the products are water, H2O, and calcium phosphate, which has the formula Ca3 and then PO4 in parentheses times 2. Now the PO4 atom group is multiplied by 2 on the right, giving us 2 atoms of phosphorus. I'm not going to talk about the oxygen atoms for right now, because there is oxygen in every single formula, so we'll deal with that later. But to balance the 2 phosphorus atoms, let's place a 2 in front of the phosphoric acid. Now, there are 3 calcium atoms on the right, so let's balance the calcium atoms by placing a 3 in front of the calcium hydroxide. All right, how many hydrogen atoms do we have on the left? Well, 3 times 2 is 6, plus another 2 times 3 is 6. There is a total of 12 hydrogen atoms on the left. We can balance the hydrogen atoms by placing a 6 in front of the water. And if we check, there are a total of 14 oxygen atoms on both sides, and so the equation is balanced. So oxygen on the left would be 3 times 2 is 6, plus 2 times 4 is 8. So 6 plus 8 is 14. And on the other side of the equation, 6 times 1 is 6, plus 2 times 4 is 8. 6 plus 8 is 14. The equation is balanced, and the coefficients from left to right are 3, 2, 6, and 1. Our next equation starts with hydrochloric acid, HCl. It reacts with magnesium hydroxide, Mg, and then OH in parentheses times 2. The products are water and magnesium chloride, MgCl2. Let's balance the chlorine atoms. We have 2 on the right. Let's put a 2 in front of the hydrochloric acid. The oxygen atoms can be balanced by placing a 2 in front of the water, so that we have 2 oxygen atoms on both sides now. How many hydrogen atoms are there on the left? Well, 2 plus 2 is 4. And on the right, 2 times 2 is 4. So the equation is now balanced, and the coefficients are 2, 1, 2, and 1. For our next equation, we start with potassium hydroxide, KOH. It reacts with sulfuric acid, H2SO4. The products are water and potassium sulfate, K2SO4. We can balance the potassium atoms. There are 2 on the right. Let's place a 2 in front of the potassium hydroxide. There are a total of 4 hydrogen atoms on the left. So 2 times 1 is 2, plus another 2 makes a total of 4. Let's put a 2 in front of the H2O on the right. So now there are 4 hydrogen atoms on both sides. How many oxygen atoms are there on both sides? Well, we have 2 plus 4 on the left, and we have 2 plus 4 on the right. If we check, the equation is balanced, and the coefficients from left to right are 2, 1, 2, and 1. The next equation starts with a chemical called butanol. It has the formula C4H9OH. Now the hydrogen is written twice, but that is the way the formula is normally written. So there are 10 hydrogen atoms in that formula. It reacts with oxygen, which is diatomic, and the products are carbon dioxide, CO2, and water. We can balance the carbon atoms by placing a 4 in front of the carbon dioxide. Since there are 10 hydrogen atoms on the left, let's place a 5 in front of the H2O. Now to count the number of oxygen atoms on the right, that's going to be 4 times 2 is 8, plus another 5 oxygen atoms from that water, so 8 plus 5 is 13. We already have a single oxygen atom on the left, which is part of the butanol formula. So we need a total of 13. If we place a 6 in front of the O2, 12 plus 1 is 13. So now the equation is balanced, and the coefficients from left to right are 1, 6, 4, and 5. The next equation starts with a chemical called pentane, C5H12. It reacts with oxygen to produce carbon dioxide and water. Since we have 5 carbons on the left, let's balance the carbon atoms by placing a 5 in front of the carbon dioxide. We have 12 hydrogens on the left, so let's place a 6 in front of the water. On the right, the total number of oxygen atoms is 5 times 2, which is 10, plus another 6 from the water, so 10 plus 6 is 16. We can balance the oxygen atoms by placing an 8 in front of the O2. 8 times 2 is 16. The equation is balanced, and the coefficients from left to right are 1, 8, 5, and 6. Moving on to the last chemical equation in this video, we start with octane, which has the formula C8H18, and it reacts with oxygen to produce carbon dioxide and water. There are 8 carbons on the left. Let's put an 8 in front of the carbon dioxide. There are 18 hydrogens on the left. Let's put a 9 in front of the water, so 9 times 2 is 18. How many oxygen atoms are on the right? 8 times 2 is 16, plus another 9 oxygen atoms from the water. 16 plus 9 is 25. Let's go ahead and use a fraction to balance the oxygen atoms, and then we'll fix it. So 25 is the number of oxygen atoms on the right. Let's place 25 over 2, or you could say 12.5, in front of the O2, which does balance the equation, but now we have to get the lowest possible whole numbers. So we have to multiply each coefficient by 2. And when we do this, the coefficients from left to right become 2, 25, 16, and 18. And the equation is balanced. Well, this takes us to the end of our video. I hope that this was helpful in teaching you how to balance chemical equations. Thanks for watching.